Prove the inscribed quadrilateral theorem. Given quadrilateral EFGD is inscribed in circle C, prove that angle E and G are supplementary and F and D are supplementary. So follow along here, guys. This gets to be a bit of a doozy. We're going to make statement, and we're going to justify that statement. So the first thing I want to notice is that the measure of arc DEF plus the measure of arc DGF equals 360 degrees, yeah? Because this plus this is the whole circle. And the same story, and you know what? We're going to go ahead and do these separate, okay? And that is by the, that's the arc addition postulate. Okay, now furthermore, notice that since these two added up, let's see, DEF plus DGF is 360. Let's go ahead and talk a little bit about these actual angle measures, angle E and angle G. So the measure of arc DEF is equal to twice the measure of angle E, and the measure of arc DGF is equal to twice the measure of angle G, and that was by the measure of inscribed angles theorem. But since I know that's true, I can replace DEF with two measures of angle E, and I can replace DGF with two measures of angle G. So using substitution, that means that two measures of angle E plus two measures of angle G are equal to 360 degrees, and that's the substitution property. Now, if I divide both sides by 2, and by the way, that would mean that you would divide each term here by 2. Usually when I divide both sides by 2, I divide each term by 2 like that. Then I get that the measure of angle E plus the measure of angle G is equal to 360 divided by 2 is 180 degrees, which, by the way, I got that because of the division property of equality. So I know that I know that angle E and angle G are supplementary. And I know that because of the definition of supplementary angles. They add up to 180 degrees. So you can actually run angle F and D through the exact same process, but we actually don't need to, because we know that the measure of angle E plus the measure of angle G plus the measure of angle F plus the measure of angle D is all equal to 360 degrees. And that's because of the interior angles of a quadrilateral add up to 360 degrees. You might remember that from a previous lesson. I've run out of room, so I'm going to have to continue my statements and my justification for those statements over here. But since I know that angle E, I'm going to do a different color here. Just because I know that angle E and G both come together to make 180 degrees. I'm going to replace them with 180. That is 180 degrees plus the measure of angle F plus the measure of angle D equals 360 degrees. And I know that through substitution. I subtract 180 from both sides. So I know that the measure of angle F plus the measure of angle D equals 180 degrees by the subtraction property of equality. And so now I know that the measure, now I know that angle F and angle D are supplementary by the definition of what it means for something to be supplementary. Whew! QED. Told you. Circumscribing a circle around a triangle. Okay, this isn't so bad. So use a compass and straight edge to construct a circle that is circumscribed about triangle ABC. So we're just going to follow the steps. Draw a bisector. Draw the perpendicular bisector of AB. So to draw the perpendicular bisector of AB, what you're going to do is you're going to take your compass and you're going to center it at B or A. It doesn't matter which one. Oops, that is a ski-wampus compass. Try that again. And you need to make sure that that's a little bit longer than halfway through A and B. I didn't actually check how long that was, and that's really important because you have to keep the measure the same. 1.2 inches. So now I'm going to get 1.2 inches on here. All you have to do is keep it open to the same. Right there. All you have to do is keep it open to the same amount. And there it is. So here's the perpendicular bisector of AB. Ugh, kind of. Let me try that again. Yeah, there it is. That's better. There's the perpendicular bisector to AB. Draw the perpendicular bisector of BC. So you're going to do the same thing over here. I'm going to do it in a different color. And I'm going to make it thinner too. Get that in blue. So BC, so we're going to do the same thing. Center at B. I'm going to make this one 1.15 inches, and then this one needs to also be 1.15 inches. And then you can connect the places where those two circles meet. Right here. Okay? Now place the compass at D, because we're going to mark the place where those two perpendicular bisectors meet. So that's going to be right here, and we're going to call that point D. And we're going to put our compass at D and then make a circle that goes around the vertices. That is, take your compass, put the pointy end on D, bring your compass out to any of the vertices, and it will go through all three of them. All three vertices just perfectly. Very good. There it is. Inscribing is the other way around. So we're going to draw the angle bisector of A to start. Now to do the angle bisector, you're going to start by opening your compass, put it on A to any width. Doesn't matter. And then you're going to make two circles of the same width, except at the points that intersect here. So there's one right here. There's one right here. So you're going to open it to a different width now. And I think what I'll do is I'll make different widths, different colors. So do there, and let's just do 1/2 inch. And then this one you're going to do 1/2 inch. Which means that the angle bisector is going to go from A through there. Okay? Step 2, draw the angle bisector of C. Draw the angle bisector of C. So again, to any width you want, to the orange here. Oh, that's a line, not a circle. So to any width C, oh, that's supposed to be orange because I'm trying to make it so that all the different widths, to any width here, and then from those points where it intersects the triangle there, you're going to open it to a new width and keep it the same amount open. Oops, I didn't pay attention to what that size was. So from here, I'm going to make it nice and big. 0.7. From here, 0.7. And so the angle bisector is where those two meet. Right there. Now let's get to it. So now we're going to draw a perpendicular line from D to AB. From D, so we're going to call this new point D. I'm going to draw a perpendicular line to the other side, which is going to be done like this. If you take your compass and at D, there you go. I'm going to make that a different color so you know it's a different circle. Already used blue, pink. There you go. That was a circle that was something I made at D. Let's see here. And then from the 2 points that I've intersected with my pink circle, I'm going to open up my circle to one last length. What have I not used yet? I haven't used this noxious green. Open it to any width, but just make sure it's the same. I did 0.65 here, so I got to do 0.65 here. And where they intersect, that's going to be a line that's perpendicular to AB. And then you're finally going to do your answer as a circle centered at D that goes through that place that you just marked right here. That is this place where that perpendicular line, and it goes through D. There it is. Okay, I believe that's all. Okay, there it is, folks. So there's your inscribed angles and arcs. That's all I got for you. If you have any questions, make sure to send a message to your instructor. This is Mr. P signing off, and I hope you have an excellent rest of your day.